Hello students, so today I'll be explaining an array program. So this is from the solve exercise from the array chapter. This is solve exercise question number 31. So program to convert an integer number into its binary equivalent. So we have always mentioned that the integer values, the computer converts it into binary language, right? That is zeros and one. So now using this C++ program, we shall see how an integer value gets converted into its equivalent binary number, right? So here you can see that in the main function body you have declared the variable I. This is the counter variable, and here we have declared a variable num, which is of type long int. So it is also of integer data type, but the but here the modifier long represents that this variable can store larger integer numbers values of size. So the range of the memory size that it occupies by this long int is 4 bytes. So a normal integer will occupy 2 bytes of memory, so long int will occupy 4 bytes of memory because it can accept larger range of integer values. So since binary numbers are of larger range than its integer, so that's why here we use long int. Then here we have declared the variable decimal. Then here we have declared an array of index 20 subscript 20. So here another variable d1, then d2. Yeah, so here this variable d2 is not needed. Okay, so here I've just shown you that, so you don't need to you just delete this d2, because as you can see that in the program the variable t2 is not mentioned at all. Okay, so that is the printing message, so you can correct that. And here q and then r, so this q stands for the quotient and then r stands for the remainder, right? So now after declaration of the variable, the next step is a prompt from the monitor screen. So here cout, enter any integer number. So now you're so using the C input stream, you are going to store the value in this variable num, any integer value. Then again cout binary equivalent is, so now you get to process the output. So for that the formula logic has to be applied here. Suppose if num equals to 0, so comparison has to be made. So if you enter the value 0, if you enter the value 0, then cout will display the binary equivalent, that is 0 0, and then 0 will be assigned to the variable d1. So automatically this value 0 0 will be printed out when you enter the number as 0, since the binary equivalent of 0 is 0 0, right, or 0. So here num 0, that is num value, that is 0, will be assigned to the variable d1. Then I will be initialized to the value 0. As you can see, this is the format of the while loop. The counter variable gets initialized, the while test condition is done. If it is true, the body of the while loop gets executed and I gets incremented or decremented. So here the formula is applied. So this I shall explain through a dry run method. So here r equals to d1 mod 2. So you take the modulus, that is here you take the remainder, and q equals to d1 divided by 2 here. So q is, you take the quotient, and then xi, so here the array stores the value of the remainder, right, and d1 stores the value of q, then I gets incremented. So as long as d1 value, that is not equals to 0, so in the case of num 0, so 0 is not equal to 0, right? So as long oh, in the case of this one, 0 is not equal to 0, which is false, right? So what will happen is that when num equals to 0, the while test condition will the body of the while test condition will not execute, because 0 not equals to 0 is false. so 0 is equal to 0, right? So this body of the while loop will not execute. After that, it comes here, j equals to I. The value of I is assigned to j, so now j will be 0. Then cout slash n, do the cursor will move on to the next line, a new line, right? Then if num is greater than 0, that is 0 is greater than 0, right? But 0 is not greater than 0, right? So in that case also, the for loop in the body of the if block, the for loop will not execute, and then you'll get the output, that is cout 0 0. But if you enter any other number other than that, then this while loop, the if block, the for loop also will get executed. So let's run this program and see what kind of output you get, right? So now enter any integer number. So let's say you enter 0. So you are getting that binary equivalent is 0 0, right? Now let's again run another compile and run it. So I say let's say we enter 8, so integer 8. Now the binary equivalent is 1000. So you can check this in the number system chapter. You will see that the binary equivalent of 8 is actually 1000. Now let's verify that using the truth table, the dry run method, right? Sorry. So here we have the dry run method. So as you can see that this is from the solve exercise question number 31, right? So here half of the program is just written here, and this is the dry run method, the table. So at the beginning, these are the variables that are declared, and here when you enter, so if you enter 0 and num is assigned the value 0, then the next step is binary equivalent will be displayed, and then if 0 equals to 0, which is true, right, then execute the cout statement, that is cout 0 0. After that, 0 will be 0 here, yes, 0. So here 0 will be assigned to D1, right? So now when you assign 0 to D1, the next step is the after that, the next step is I will be initialized to 0, and then the while loop will execute. So here you can see that I equals to 0, so 0, while D not equals to 0, 0 not equals to 0, which is false. So the body of the while loop, the while test condition will not execute. Then it comes here, j equals to I, so 0 equals to 0 is assigned to the variable j. Now if num is greater than 0, 0 is greater than 0, which is also false. So the if block will not execute, that is the for loop will not execute. Then what will happen is that you will get the output, that is 0 0. Now if you enter any integer number, if you enter 8, 8 is stored in variable num, then binary equivalent is if 8 equals to 0, comparison is done. Is it equals to 0? No, so false. Then so when it is false, the cout statement will not execute. Alright, then it comes here, 8 is assigned to the variable D1. Then again I is initialized to the value 0. So while D1 not equals to 0, so D1 is 8, right? 8 is not equals to 0, which is true. So the formula gets executed. R remainder equals to 8 mod 2. When you divide 8 by 2, you get the remainder 0. So now remainder equals to 0. Then Q equals to, when you divide 8 by 2, you get the dividend as 4, right? So here 4. Then X I. So this is the array element. So this in this array element x0, the value 0 will be stored because xi equals to r, right? So now in the first array element x0, 0 will be stored, that is the remainder value. Then d1 will be assigned the value of q, which is 4. Then I gets incremented, I equals to here 0 plus 1, so which is 1. Then after that I becomes 1. Now again, while d1 not equals to 0, what is the value of d1? now d1 has been assigned the value of q, right? So that is 4. So 4 is not equals to 0, true. Then r equals to d1 mod 2, that is 4 mod 2. Again you get the remainder 0. Then again q equals to d1 divided by 2. So d1 is 4. 4 divided by 2, you get a dividend 2. Then x1, now I has incremented to 1, right? So now the next array element, so you see that the compiler automatically creates the array element or the variable to store the value. So here x1 will be again 0, that is the remainder. Then d1 will be 2, which is q value. Then I gets incremented to 2, then it comes here. So 2 not equals to 0, right? 2 is not equals to 0, which is d1. d1 is not equals to 0, which is true. Then again remainder is equals to 2 mod 2, where you get 0. q equals to 2 divided by 2, so 2 1 2, so the dividend is 1. Then the next array element is created, which is x2 equals to the remainder 0. So d1 is 1. Then I gets incremented. Now again d1 is tested. 1 not equals to 0, which is true. Then remainder equals to 1 mod 2. So when you divide 1 by 2, you get the remainder as 1. That is 2 into 0 equals to 0, right? So you get 1. Then here you get the dividend as 0. So 1 divided by 2, right? So you get 0. So now the array element x3 stores the value of remainder 1. So d1 will store the value of q, which is 0. Then I gets incremented, so 4. So now what is the value of d1? 0, right? So while 0 not equals to 0, which becomes false, so you exit the loop. So after exiting the loop, you come here. Now what is the value of I? I value is still 4, right? So now 4 is assigned to j. Right, so now j will take the place of j will store the value of I, which is 4. So now if num greater than 0, what was the value of the num we stored? That is 8, right? So here 8 is greater than 0, yes. So keep in mind that the if test condition will be executed only once. So that's why in the if block, inside the body of the if, you have the for loop. So only this for loop test condition will keep on executing. So as long as this test condition holds true, the for loop will keep on repeating. So here I equals to, what is the value of j minus 1? That is initially j equals to 4, right? So 4 minus 1, which becomes 3. So now 3 is greater than 0, which is 3, right? I is greater than equal to 0, which is true. Then what is the so cout will display xi. So now xi, what value of I it is? 3, right? So in the third so in the array element x3, what value is stored? If you see the previous table, xi equals to r, right? And here x3 stores the value 1. So now 1 will be displayed first. So when the cout will be run, you will see that 1 will be displayed first. After that I gets decremented, so I equals to 3 minus 1 2, right? Then after that we come back to here, right? So now sorry, this is initialization, right? So here remove this, right? So now after that, keep in mind that initialization will be done only once. Now after that, after this I value gets decremented, the test condition is done again. 2 is greater than or equal to 0, which is true, right? So again xi, which is x2, equals to, what is the value stored in x2? 0, right? Then after that I gets again decremented, reduced. 2 minus 1 1. So test the condition. 1 is greater than or equal to 0, true. x1 stores the value 0, right? Again I equals to 1 minus 1 0. So now 0 is greater than 0, no, but 0 is equals to 0, right? True. So now x0, which stores the value 0, is displayed. So 1 0 0 0 is displayed. Then again I gets decremented. 0 minus 1, you get minus 1. So here -1 is greater than 0, no. Is equals to 0, no. It's less than 0, right? So false, you exit the loop, and then you get the output 1000. All right, so likewise you run some other integer numbers, and then compare that with the ASCII table, which is there in the number system chapter. Okay, and then you will see that you get the exact equivalent of the binary number for that particular integer value. Okay.